Okay, so good morning, good students. So today we are going to proceed from where we left last time. So we are still busy revising this question paper that was written last year in May, June 2020. We were at question number 7, and question number 7 is written, prove the identity 1 plus sine theta over cosine theta plus cosine theta over 1 plus sine theta is identically equal to 2 over cosine theta. How are we going to prove this identity? Let's take a closer look at this identity. We have this side. This is our left hand side. We also have this term. This is our right hand side. So for us to prove this identity, we need to prove that the statement that is on the left hand side is equivalent to the statement that is on the right hand side, or vice versa. We can also even prove that the right hand side is equivalent to the left hand side. But for you to do that, you need to be very, very, very careful when you're choosing the side that you need to deal with. You can't take the side that is more simplified. For example, in this case, it is a bit tricky to take the right hand side and try to work it out until you get the left hand side. Why? Because the right hand side is already more simplified. So in this case, we are going to choose the left-hand side because the left-hand side is less simplified. So we can start simplifying the left-hand side until we get the right-hand side. So in this case, we are going to consider the left-hand side. So what is written on the left-hand side? We have 1 plus sine theta divided by cosine theta plus cosine theta divided by 1 plus sine theta. This is quite interesting. Look, what is going on here? We are adding two fractions. We have the first fraction with the numerator 1 plus sine theta and the denominator cosine theta. We also have the second fraction that we are adding with the numerator cosine theta and the denominator 1 plus sine theta. You need to recall the concept of fraction addition. Let's take, for example, we've got a fraction a over b that we are adding with another fraction c over d. How do we add fraction? Remember, the common denominator here is basically bd. You say the b into bd, you get d, and b times a, you get ad. B into bd, you get b, and b times c. By the end of the day, you get bc. So yes, this is how we add fractions according to what we've covered in primary school. So now you may find out that for us to add these fractions, we also have to carry out that same concept I have outlined here for fraction addition. So in this case, this fraction plus this fraction, the first thing we are going to write down our common denominator. It's very simple to get the common denominator. Simply take cosine theta, multiply that by 1 plus sine theta. So yes, this is our common denominator. And then the next thing, we then set cosine theta into this common denominator. So cosine theta will cancel cosine theta, so we remain with 1 plus sine theta. So that 1 plus sine theta, we multiply with another 1 plus sine theta here, we get 1 plus sine theta times 1 plus sine theta. Okay, and then the next thing, we say 1 plus sine theta into this common denominator. So 1 plus sine theta cancels 1 plus sine theta, then remain with cosine theta. So cosine theta times cosine theta, we get cosine theta times cosine theta. Okay, so on the next step, we have to simplify our single fraction. So what is 1 plus sine theta times 1 plus sine theta? So this is an expression that is multiplying another expression. So remember how we expand expressions of this form. So whenever you are removing double brackets, multiply the second expression by each and every term in the first bracket. So a is going to multiply, 1 is going to multiply with 1. This one is also going to multiply with sine theta. And then after that, this sine theta is also going to multiply with 1. And this sine theta is also going to multiply with sine theta. So what do we get by the end of the day? It's quite interesting. Watch out. So if you say 1 times 1, you get 1. 1 times sine theta, we get sine theta. If we say sine theta times 1, we get sine theta. If you say sine theta times sine theta, you get sine squared theta. Plus cos theta times cos theta, we get cos squared theta. There's something that I want to caution you students. Please remember, if I say cosine theta times cosine theta, mathematically this is the same as cosine theta in brackets to the power of 2. Or you can write this as cosine squared theta. Don't ever write it as cosine theta squared like this. That is very, very wrong. Okay, so here our common denominator all over, what is the item that we have on the common denominator is cosine theta, open brackets, 1 plus sine theta. So on the next step, 1, we're going to keep our 1. If we say sine theta plus sine theta, so we've got 2 of these sine thetas. So we've got 2 sine theta. And sine squared theta plus cos squared theta, if we check in our formula booklet, we know very well that sine squared theta plus cos squared theta gives us a very, very beautiful result. So sine squared theta plus cos squared theta gives us 1. So yes, here we're going to replace sine squared theta plus cos squared theta with 1. So we're going to get 1 at this point. All over cosine theta, open brackets, 1 plus sine theta. Okay, so on the next step, what is 1 plus 1? Hey, we know the answer that it is 2 plus 2 sine theta all over cosine theta, open brackets, 1 plus sine theta. Okay, let's quickly move on to the next step. So here we can see that 2 is the highest common factor on the numerator. So we can factor out 2. We factor out 2 and say 2 into 2, we get 1. And 2 into 2 sine theta, we get sine theta. All over cosine theta times 1 plus sine theta on the denominator. I want you to watch out something quite interesting here. We have a common factor. We have 1 plus sine theta here on the we have 1 plus sine theta here on the numerator, and we also have 1 plus sine theta on the denominator. So we can cancel out those common factors. And then by the end of the day, our result becomes 2 over cosine theta. Exactly. Let's check. This is indeed the term that we have on the right hand side. So this is exactly the same as that we have on the right hand side. So hence proven. You can put a tombstone at the end to show that you have indeed proved the identity. So yes, that's how we're supposed to prove this identity. Um, Taking the side that is less simplified, which is the left hand side, and then we have to simplify that left hand side until we get the expression that is indeed on the right hand side. So with this at hand, yes, you deserve to get how many marks are there? You get all these 3 marks. So how are these marks are awarded? What was very important here to apply the concept of fraction addition, the one that you have learned in grade 5 in primary school. That was very important for you to get the first mark. And then the second mark we're going to be awarded after simplifying here to understand that sine squared theta plus cos squared theta is equal to 1. That was another identity. To factorize and cancel out the common factors, then indeed you can get another mark. So yes, this was indeed an interesting question, and this is exactly how we were supposed to tackle it. Awesome.